Hello, Nick Hodges here, Senior Developer at Gateway Ticketing Systems, and I'm here to talk to you today about Dependency Injection Basics for today's Developer Skill Sprint. This skill sprint will work with any Embarcadero development tool. The principles I'm talking about today are not specific to Delphi or any language or framework, so they'll work on all the platforms that Delphi and C++ support, as well as App Method. These principles will work for Object Pascal and C++. Although I'll be doing all my demos in Object Pascal today. So here's what we're going to cover. We'll cover the basics of dependency injection. I'll have one slide that'll talk a little bit about it. Then I'll show you some demonstrations of code that show what's commonly referred to as poor man's DI, or poor man's dependency injection, which is a very simple technique, but a very powerful one. Then we'll leverage some interfaces to show you how interfaces can be used with dependency injection to separate you from the implementation of any particular class. And then I'll show you the proper use of a DI container, the right way to use them as opposed to the wrong way. So what is dependency injection? Well, dependency injection is really a $25 word that describes a 10-cent concept. Dependency injection is simply the notion of not letting classes create their own dependencies, but instead give a class its dependencies. It's that simple, really. There's really nothing more to it than that. It allows you to decouple your dependencies from any specific implementation. This allows you to create, for instance, testing classes that you can inject into your classes as dependencies to enable you to more easily and powerfully test your applications using unit testing. Okay, so at this point, let's just go right to the code demonstrations. Okay, here we are in Delphi XE8. I've got 5 demos. Each one builds on the previous one, and I'll show you them one at a time. The first demo is a pretty typical way of doing business in Delphi. We have 3 classes, a sprocket verifier, and a sprocket processor. The sprocket processor takes a sprocket and processes it using the sprocket verifier. Pretty simple stuff. We see this kind of class hierarchy all the time. Now, in the constructor, you'll see that we take a sprocket to be processed in the constructor as a parameter. We store it off, and then we create an instance of tsprocket verifier. Now, this is a very typical construction in Delphi. We create a sprocket verifier in the constructor of sprocket processor and then destroy it in the destructor. Pretty normal. However, if you stop and think about it, what we've done is we've tightly coupled ourselves to the specific implementation of tsprocket verifier, and that is something that we want to avoid. So in the next demo, we'll see how we can take a step towards avoiding that. Okay, so here we have the second version of the demo, and you'll notice that it's got the same 3 classes as before, only this time the constructor takes as a parameter an instance of tsprocket verifier, and then the constructor looks like this. It simply checks to make sure that it's not past nil, anything nil. Those are called guard functions. And it stores the sprocket and the sprocket verifier off for later use. So when you call process sprocket, you can use the fsprocket verifier instance to verify the sprocket and process it completely. So what we've done here is we've eliminated the specific dependency on a given instance of tsprocket verifier and allowed you to pass that instance into the class. And this is the very basic form of what's called constructor injection. And in a sense, I could stop the talk right here because that is the essence of dependency injection. You give the class the implementation of the class it needs. You don't create it yourself. And so that's the basic premise of constructor injection and dependency injection in general. And now we have our third demo. And in this demo, we're even further abstracting away the notion of what a sprocket verifier are. We've created a demo interfaces unit that defines 3 interfaces, 2 of which we'll use in this demo, the iSprocket and iSprocket verifier interfaces. We then implement those interfaces using the tsprocket and the tsprocket verifier classes. And instead of passing in actual instances of those classes to the tsprocket processor, we are going to pass in interfaces, thus further insulating ourselves away from any particular implementation and instead coupling ourselves to an interface, which, as I've said before, is kind of like trying to grab onto a wisp of smoke. It's really nothing. It's really just a declaration of an implementation. Now we have truly completely separated ourselves from the implementation of the sprocket verifier. So when we look at how this particular class is implemented, you'll notice that we declare two interfaces and a sprocket processor. We create the sprocket and sprocket verifier, and we pass those interface implementations into the sprocket processor, which in turn processes the sprockets. So we've completely decoupled the sprocket processor from any particular implementation. We could implement any kind of sprocket we wanted, any kind of sprocket verifier we wanted here, and pass those to the sprocket processor. Now, you can see that if we continue to do this with more and more classes as our application becomes more complicated, we're going to end up with a whole lot of classes being created and interfaces being implemented in the DPR file. And so you could imagine that there might be a huge stack of things that get created inside that DPR file as the application gets more complex. So the way typically you deal with that is through a dependency injection container, and that's what we'll take a look at in the next demo. Okay, here in our fourth demo, we'll see our first use of the global container or dependency injection container defined in the Delphi Spring framework. The classes here that we'll use are exactly the same as they were in the previous demo. Only now we're going to register the sprocket, tsprocket, and tsprocket verifier as implementing specific implementations. This will enable the global container to create an instance of tsprocket whenever we ask for a interface of isprocket, and same with the tsprocket verifier class. This enables us to then create an instance of a sprocket using the global container.resolve call. And we simply ask for an instance of isprocket, and we get whatever is registered to that sprocket, to that interface in the global container. The same occurs for isprocket verifier. We then can pass those instances into the sprocket processor and process sprockets normally. You notice again that the sprocket is an interface and the sprocket verifier is an interface as well. This is the global container in action here. It is going to allow you to create instances quite simply and easily through the process of resolving interfaces. However, if you think about it here, all we've done is replace the construction, direct construction, with some indirect construction. And we haven't really gained all that much in doing so. You can see as our application would get more complex, we simply would just have a stack of global container resolve calls as opposed to a stack of constructor calls. So what we want is a way to simplify the creation of our object graph, of our object structure, and we want to be able to do it with a single call to the global container. That enables us to not depend heavily on the global container. It helps us to create a stack of classes that can easily be called and created with a single call to the global container, thus simplifying our application and enabling us to fully decouple ourselves from any given implementation while using the global container to create all of our objects for us. So here in our fifth and final demo, we have created three classes that are now completely constructor injectable by using these interesting attributes. And we'll talk a little bit about how they work here. So first of all, we still have our three basic classes, but now they're all implementing interfaces, including tsprocket processor. But tsprocket processor has this notion of injecting isprocket verifier interface into the class itself. And in addition, we also inject the constructor. And what these attributes do is they tell the global container to automatically create instances of these parameters and this field when this parameter and those fields are first used. And in fact, what that means is you don't even have to create a sprocket verifier. You don't even have to pass in a sprocket verifier. You just simply have to inject the field value automatically. And because the implementations are all registered against the specific interfaces, and because T-Sprocket processor itself is registered in the global container, we can use the inject attribute to tell the container to automatically create it on first use. And so you can see that the constructor, for instance, doesn't even know anything about F-Sprocket verifier. And in fact, the constructor also, you'll note, and the DPR file itself doesn't do anything other than create a Sprocket processor using a single call to the global container, and then allows it to process sprockets. And just to prove that this works, we'll press the run button, and you'll see the sprockets are properly processed. And again, I want to stress that these inject attributes work because the Sprocket processor class is registered with the global container, and because we use these inject attributes to tell the global container to create an instance of T-Sprocket verifier or whatever is registered against the I-Sprocket verifier interface upon first use. And that is a very powerful technique that allows you to keep your application core, the application root, very simple. One call to one class. All the constructors of the needed interface, needed implementations of the needed interfaces are all automatically created for you as you do that. And this, you can use the Sprocket processor with this simple 3 lines of code. Register everything, call a single global container, call to the Sprocket processor, and we are past a completely created Sprocket processor with all of its dependencies injected into it. And that is the basics of dependency injection. There are lots of learning resources about dependency injection out there on the web. You can search Google with them. But I'd like to recommend 2 books. Of course, naturally, I recommend my own book, Coding in Delphi, which has 2 chapters on the dependency injection, as well as Mark Siemens' book, Dependency Injection in .NET, which is an excellent resource for learning about dependency injection. Don't be deterred by the C# code. It's very easy to read, and the book isn't really a C# book. It's a dependency injection book. Recommend both of those to you. Next up for the developer skills sprints is the IDE integrated project source control using Subversion Mercurial and Git. That's next Tuesday at the times you see there, and I believe that's given by Robert Love. Rad Studio XE8 has got a special going. You get some free bonuses. You get the VCL FireMonkey Premium Styles, Marco Cantu's new Object Pascal book, and the MIDA converter. You also get a new copy of my book, More Coding in Delphi, as part of that Rad Studio offer as well. Go to the Embarcadero website to find out more. And now it's time for questions.